The purpose of this lesson is for you to learn about the wrapper classes and how to use the wrapper classes as both utility classes and also as a means of accomplishing certain things with primitive variables that you couldn't ordinarily accomplish. Now let me give you an example of the last thing. I'm gonna crank up my J shell here, and I'm going to make an array list. And I'm all of a sudden interested in having an array list of integers, and I say AL is new array list, and foiled. Error, unexpected type, required reference. In other words, the only types that can be type parameters in a generic class such as ArrayList are object types. You cannot do this with primitive types. And you might think, well, maybe a really smart way around this would be for us to write a class that just holds an integer. And maybe we'll make that class immutable and make that integer very accessible. Well, you don't have to do that because Java already provides that. Every primitive type has a wrapper type. So let's talk about integer because that's a pretty common workaday thing that we use. The wrapper type of integer is for int is capital I integer. And here's how you can make one. You can just say this. Now, what has happened here, what you're seeing here is a process called autoboxing. It took that raw little I integer and it promoted it to a capital I integer. A capital I integer is much like Python's integer, only it does not have unlimited precision as Python integers do. So we just promoted that to an integer. So we can now do something like this. Array list of integer. AL is new array list. Come on, capital A. You're there when I don't want you to be. Oh, look at that. And AL.add of, I don't know. There we go, some nice number there. And there you go. So that's one nice thing about these wrapper classes. But it's not the only nice thing. The wrapper classes have certain methods in them that you're going to find handy. And so we're going to walk through the API guide and demonstrate some of these things so you can see them for yourself. Let me put this away, and let me put this away. I got too many toys out of my toy box. All right, so here's the API guide. And let's go here, and we'll see certain things that all the wrapper classes have in common. Integer. So we're going to pull up integer, class integer. The integer class wraps a value of primitive type int in an object. An object of type integer contains a single field. In other words, field is another name for state variable. It has a state variable whose type is int. In addition, this class provides several methods for converting an int to a string and a string to an int, as well as other constants and methods that are useful when dealing with integers. Okay. So let's take a look in here and see what some of this. First of all, there are static constants, okay? And you're going to see that all of the wrapper types have static constants like this, of a similar sort. So I'm going to say integer, and it's going to tell me my integer type is 4 bytes wide. Now, I may as well introduce some of the names of the other wrapper types. No surprise that byte byte is 1 byte wide. Short, get shorty, bytes is 2 bytes wide. Int we saw, and long is 8 bytes wide. Okay, let's try this. Float. So you're seeing capital I integer is int, capital byte is bytes, capital S short is short, capital L long is long. I don't know why they didn't just say capital I int to be consistent. That's kind of irksome, but you have to remember that exception. Languages are often irrational. Okay, because they're the product of humans, which are also irrational. All right, so here's double bytes. All right, character dot bytes. Character is the wrapper for character, and Boolean. Ooh, it doesn't have a bytes symbol. So we got bitten by the interpreter. But you can see the 4, so we've seen the 1, 2, 3, 4 integer types, float and double, and character. Boolean does not have a bytes method, or a bytes constant. So that's a static constant, and you can tell it's a constant because the letters are capitalized, and that's the convention in Java for constants. In fact, it's the convention in a lot of languages. The same thing. Integer has a max value and a min value. They will tell you the maximum and minimum values of integers. Now it's a little exercise for yourself. You can stop this video and try max value and min value for the other numerical types and see what it looks like. This is a useful exercise, and I recommend you take a couple moments to play with that in JShell and then come back to this. Okay, next item we'll look at. So we're just doing a grand tour here, okay? There are some other things here like size and type. I'm not going to worry about those right now. Now you'll see there's a constructor. You can make an integer by going integer I is new integer of 5, or a string, but these are deprecated. Don't bother, because how did we make an integer? We didn't need new. All we had to do was go integer, and there we go. Forget that constructor. It's obviated by autoboxing. Okay? Autoboxing takes care of that. Now we have some things in here that are, there's a lot of static items in here. A whole lot of static. There's static and instance both. All right. Byte value of an integer. Oh, let's play around with that and find out what's going on here. So I'm going to say integer foo is equal to 129. And then I'm going to find out what its byte value is. Ew! That's nasty. What happened? Now, we know that bytes go between minus 128 and plus 127. So when I did 129, I went 1 over, and that went to negative 128. And then I went up another, and now I'm at negative 127. So you, caveat emptor here, you got to watch out. Hopefully your value is short enough that you won't get that kind of type overflow error. Here we have compare. You can use it, but, you know, I would just do this. If I go integer small equals 4. Oh, 34 is good enough. Integer big equals 45. Hey, let's try that again. Okay. Let's try big. Small, less than big. Autoboxing takes care of that. That was auto unboxing. Because what it did is it just unboxed the two integers from the integer objects, compared them, and returned the result. Okay? So that's fairly straightforward stuff. We can deal with that. But there are some things that are actually kind of handy in here, and I'm going to find the handy things. Okay. There's max and min. That's kind of handy for integers. So you don't have to use math.max. You can use integer.max. Okay. That's actually a pretty dang nice thing. That's useful. Okay. So you can, because if you do math.max of 4, 5, I can't tell if that's a floating point number or not. Wait a minute. We'll find out. Interesting. Math.max is returning an integer when it's given integers. Okay, that's kind of a new and funky thing. But you can also do integer.max or integer.min if you're not sure and you know you'll get an integer. Now here's something you're going to use a good bit. ParseInt. ParseInt is the means by which we convert an integer string into an integer. So how does that work? We just say integer.parseInt, and then you put in a numeric string, and it's happy. Now, beware. Let's feed a cat into the machine. Wow! Uh-oh. We got an exception. An exception is a runtime error. The compiler will not catch that. But when your program runs and encounters this exception, kerpow! Your program is door-nail dead. So you want to be careful. How do you know if it's possible that an exception might be thrown? That's a good question. Here's how to find out. Click on a method. Right here. At the bottom, it says throws, number format exception. All exceptions, they generally have exception in the name. And if you get an exception in a running program, the running program aborts on the spot. There are ways of handling these things. We will talk about those later, but be aware that that exists. You want to make sure that you're feeding something in that's appropriate. Okay? And you can see some of these other things will throw a number format exception as well. They'll dig out a part of a string and convert. You can also do something like this. Let's go ahead and try this on for size. Watch. Integer.parseInt of this took this number and read it as a base 2 or binary number, and this works for lots of different bases. Let's try base 5. Look at that. However, if you do something like this, and you try that in base 6, punishment will ensue. Why? Because in base 6, the only acceptable digits are 0 through 5. Okay. You have a hex number. And I want it, I have a hex number, FFF, C0. Oh, let me do that again. And then you put in 16, and it will happily convert for you. Now there is a way to go the other way around. I can do this. Integer.toString. This is an interesting method. So if I put in a number, say 456, and I say 16, that'll take 456 and turn it into base 16. If I want to see it in base 3, sure. There it is in base 3. Okay, so you can convert between bases by using the static method integer.toString. There are also these value of methods. They are worth exploring as well. You might want to take a look through them. Okay, here's short value, int value, and they're basically casts that you can do. Oh, let's see what the hash code is on an integer. This is kind of cool. Oh, let's put in this integer, and let's see what it is. Oh, look at that. Hey, it just seems to return itself. Okay, so, turns the hash code for this integer. It seems like a hash code for the integer. A perfect hash code is the integer itself. So why not, right? Okay. There's an equals method, but if I do this, integer c equals 5, integer d equals 5, let's find out. C double equals D. Ooh. Although you want to be careful. I would much prefer to do this. That's probably a more reliable thing to do if you're working with capital I integers. Okay, beware, beware, beware. All right. So, there's lots of methods in here. We're not going to do nearly all of them, but we'll take a look at some of them. There's a compare to method, but you can use less than. And I think, oh, boy, you can get the number of leading zeros and trailing zeros. Yeah, there are things that are fairly arcane that are in here that we're not going to use right away. Here's a very strange, what you would get from reversing. Hey, let's take the number 6, integer I equals 6. Oh, let's just say I equals 6 because I is already an integer, I believe. We've been pounding on this already. Yep. So I'm going to say, let's see, integer dot reverse of 6, which is 110. Oh, ew. That's kind of weird. All right. Oh, it takes your 32-bit integer and reverses all of the values. It spells it backwards. Oh, weird. I don't know why you'd want that, but it is definitely present. Okay, here's min and max. Okay, so this is the integer wrapper class. Now, these classes all have something in common. One thing they have in common is this. They'll convert a string into their type. So you see boolean.parseBoolean of true or false. Double.parse double. 6.02 E23. Okay, that'll turn that into a legit double. All right, so you have wrapper type top parse, which is a very useful thing for converting things from strings to these types. So the wrapper classes are handy appurtenances. Here we saw integer, and the others are quite similar. I'm going to get double out just for fun. D-O-U-B-L-E. Let's spell it right, and maybe it will come out. Boom. Okay, here's double. Look at that. It'll tell you the maximum exponent that a double variable can have. It'll tell you the maximum value. Oh, here, let's play with this just a little bit. right? Look at that. So the largest value for a double, oh, let's try float. Is a mere 10 to the 38th. That's pretty wimpy compared to a double. This number here, 10 to the 308th is roughly 2 to the 1024th. Hopefully you can see that. I wonder why that is. That's something I'm just going to let rattle around in your brains. All right. There is something called NaN, double.NaN. That's the constant for not a number. You can see how many bytes it has. And you can see many of the same things are present. There's byte value. Oh, let's go ahead and try something bizarre. Double D is equal to 4.0 divided by 3. Okay. Now I'm going to go D dot byte. And it's like, why? What's that all about? I guess it truncates to the nearest integer and does byte value. Is that all that interesting? I don't know that it is. Okay. You can check and see if a double is a finite number. So you can do this. And a lot of times you'll do that with function values that are returned. Is finite. 4.5. Ooh. Whoops. Oh, I forgot the dot. Yeah, bah. And it'll tell you true. And it's going to tell you false there, okay? It also has a max and a min method, and you can see it has this parse double method, okay? And it also has a two-string method. But here's the way I usually take a double and make it into a string. It's kind of a nice dirty trick. You can concatenate anything to a string, it becomes a string. But that method happens to be there. You can get a hexadecimal string representation of a double. Oh, let's try that. That looks like fun. Double dot 2 hex string. Let's do this. 1.375. That's 11/8. Ooh. And let's spell double correctly. Otherwise, we're going to get a nasty ululation from the compiler. Ooh, look at that. 0x 1.6 and then P0. That's sort of like your exponent. Okay, so that converts to 1.6. And that sort of makes sense because 0.375, 6 is 3/8 of 16, and so there you go. So you'll get a nice representation provided you're using something that has a denominator of a power of 2. Let's go 5.0625 just for fun. See that? There you go. That's 14.4, it appears, is your, wait a minute, no, 1.44 P2. That's a strange thing. I don't know. I'd have to do a little looking into that sort of thing. But there are static methods in all of these. Your character in particular is got some really useful stuff in there. Yeah, let's go to character because that's one that you'll actually use quite a bit. Okay, java.lang.character. Okay. Bytes. All right. Then there's all these weird static constants for internationalization. Oh, okay. And then down here, let's see what we got that's of interest to us. Here's the thing that's interesting. Is digit. Okay. Is digit is useful. Because if you want to check if a character is a digit, there you go. There's a nice way to do it. Okay. Is letter. Okay. Now, when you see this code point thing, this is all about other alphabets. This is internationalization. Is lowercase. All right. Is space. So the most useful thing in the character wrapper class is these static is methods. And also there are things that will lowercase a character. You can see that. You can return a character as a string, but that's very easy anyway. All you have to do is take the character variable, concatenate it to a string. I don't ever do this, but here's to uppercase. So you can see there's a lot of useful static methods. Sometimes when you're dealing with different types of characters, this is a good place to go and look around. All right. So this is these are all the this is an introduction to the wrapper classes. What do you need to come away with? 1, they have useful static methods and instance methods, and you can look these up in the API guide. 2, they are extremely handy when you are wanting to make a collection, such as an array list of primitive types, because you cannot. What you do is you use its wrapper type. 3, just to remind you, going from small to large, small b byte becomes capital B byte. Small s short becomes capital S short. Small I int becomes capital I integer spelled out. Small L long becomes capital L long. Float and double the same way. Small f float becomes capital F float. Small d double becomes capital D double. Character, second exception. CHAR becomes character with a capital C. And Boolean just becomes a Boolean with a capital B. So take some time, open your Java or your J shell, and do a little exploration of these classes, because they do have useful things in them. But now you've had a little bit of a tour, so it's not quite so bewildering. And you will find them to be useful appurtenances when you're writing programs.